Have you ever felt a pull towards something you couldn't see? Our galaxy, the Milky Way, is experiencing that right now. We're speeding through space at over 2 million kilometers per hour, not aimlessly, but drawn by a mysterious force. This force is called the Great Attractor, a massive, invisible region whose gravity is warping space-time itself. Imagine a cosmic river, with our galaxy and thousands of others swept along in its current. The Great Attractor isn't a single object, but a vast concentration of matter, hidden from view and puzzling astronomers for decades. It's about 150 million light-years away, in the direction of the constellations Triangulum Australia Norma, close by cosmic standards. Yet, when we look that way, we see almost nothing, as if a curtain hides this cosmic heavyweight. The Great Attractor's pull is a silent summons, reminding us that the universe's grandest forces are still shrouded in mystery. With a mystery as profound as the Great Attractor, a cosmic force pulling on our entire local group of galaxies, the first question is always the most obvious one. Why can't we just see it? Why can't we point our most powerful telescopes in its direction and behold the source of this immense gravity? The answer is both simple and profoundly ironic. The very galaxy we call home, the Milky Way, is blocking our view. We are not impartial, distant observers of the universe. We are residents living deep inside a sprawling city of stars. Our solar system is embedded about 2/3 of the way out from the galactic center, nestled within one of its spiral arms. And it just so happens that when we look toward the Great Attractor, our line of sight takes us directly through the most crowded, chaotic, and visually opaque part of our entire galaxy, its central plane. This region is choked with a thick smog of interstellar gas and dust, a cosmic curtain woven from countless stars, nebulae, and microscopic grains of carbon and silicate. Astronomers have a name for this frustrating cosmic blind spot, the zone of avoidance. The analogy of trying to spot a distant mountain through thick fog is a good start, but it doesn't capture the full scale. This galactic dust doesn't just blur the view, it actively absorbs and scatters the light from objects behind it. Visible light, especially bluer wavelengths, simply can't make the journey through. It's a process called extinction, and in the zone of avoidance, the light from a background galaxy can be dimmed by a factor of 100 or more. For centuries, this was a source of deep confusion for astronomers. As they mapped the nebulae they believed to be distant star systems, they noticed a strange, empty band across the sky. They were avoiding this zone in their surveys simply because they couldn't see anything there. This cosmic blind spot is enormous, obscuring roughly 20% of the sky beyond our galaxy. The irony is staggering. We build instruments that can peer back to the dawn of time, yet a huge patch of the universe, cosmically right next door, remains hidden. The zone of avoidance conceals not just the Great Attractor, but an estimated tens of thousands of entire galaxies, each with billions of stars of its own. So we are left with a tantalizing paradox. We can feel the Great Attractor's immense gravitational pull. We can measure its effect on the motion of our own galaxy and all our neighbors with incredible precision. We see the evidence written in the flow of the cosmos. But the source itself, the colossal structure of galaxy clusters responsible for it all, remains shrouded behind this celestial curtain. To solve this puzzle and finally lay eyes on the Great Attractor, astronomers had to abandon the light our eyes can see. They had to find a new way to look at the universe, to peer through the dust and see the invisible. They had to turn to wavelengths of light that could pierce the veil, beginning a new era of discovery. How do you find something you can't see? It's the ultimate cosmic detective story. The suspect? A colossal, invisible source of gravity. The crime scene? Our corner of the universe. And the only witnesses are the galaxies themselves, whose movements betray a hidden influence. The solution lies in following the clues it leaves behind. These aren't fingerprints or footprints, but subtle yet undeniable gravitational breadcrumbs scattered across millions of light years. We must learn to read the motions of the cosmos itself. The first major breakthrough came in the 1970s and 80s. A team of astronomers who would become known as the Seven Samurai were mapping the motions of nearby galaxies. They expected to see the uniform expansion of the universe, with everything moving away from everything else. But what they found was shocking. They noticed galaxies weren't just drifting apart, they were streaming in the same direction, a unified, large-scale flow across a vast expanse of space. It was as if our entire galactic neighborhood was caught in a powerful, unseen cosmic current. But there was a problem. The source of this pull seemed to lie in a direction that was completely obscured from our view. This region, known as the zone of avoidance, is the dense, dusty plain of our own Milky Way galaxy. For optical telescopes, it's like trying to see through a thick, star-studded curtain. To peer through this cosmic veil, scientists had to turn to other forms of light. They used powerful X-ray and radio telescopes, whose longer wavelengths could penetrate the gas and dust that visible light could not. Slowly, painstakingly, they began revealing a hidden landscape of previously unknown galaxy clusters. And there, right where their calculations predicted, they found a prime suspect: the Norma cluster. A massive, gravitationally bound group of thousands of galaxies. It was a behemoth in its own right. It was found at the heart of what they dubbed the Great Attractor region. For a moment, it seemed the case was closed. But when they calculated its mass, the numbers didn't add up. The Norma cluster was huge, but it accounted for only a small fraction of the total gravitational force required to pull us and thousands of other galaxies at such incredible speeds. It was a major piece of the puzzle, but it wasn't enough to explain the pull. The true culprit was still out there. The search continued, pushing deeper into the cosmos. And that's when the mystery deepened profoundly. Looking far beyond the Great Attractor, astronomers discovered the Shapley Supercluster. This wasn't just a cluster, it was a supercluster, the largest and densest concentration of galaxies in our local universe. A true cosmic titan. Located over 650 million light-years away, it contains the mass of over 10,000 Milky Ways. They realized this even larger structure, lying farther away, was also a key player, and its immense gravity also tugs on us. Suddenly, the picture became far more complex and far more elegant. Our galaxy's journey is shaped by a cosmic push and pull on an unimaginable scale. Think of it like a gravitational watershed. The Great Attractor, with the Norma cluster at its center, acts as our local gravitational anchor, a nearby valley we are flowing towards. But the much larger and more distant Shapley Supercluster acts like a massive continental divide, pulling everything in the entire region, including the Great Attractor itself, towards it. We're caught in a flow between these two giants. And to make things even more intricate, recent discoveries suggest there may also be a push from the other direction, a vast, underdense region of space called the dipole repeller, which effectively shoves us away. So, the universe's structure is far more complex than a simple fall towards a single point. It's an intricate dance of massive, largely unseen forces, a web of attraction and repulsion that dictates the fate of galaxies. The Great Attractor isn't a monster waiting to consume us, but a nexus point in the vast cosmic web, a structure of dark matter and galaxies that connects everything. Each new observation, each painstaking measurement brings us closer to mapping this incredible structure and understanding the true scale of our cosmic neighborhood. The investigation continues, revealing a universe more interconnected and dynamic than we ever dared to imagine. So, what is the Great Attractor? For decades, it was one of astronomy's most profound puzzles. We saw our own Milky Way and all our neighboring galaxies being pulled with immense force toward a specific point in the sky, a point obscured by the dense dust and stars of our own galactic plane. It was a ghost in the cosmic machine, a gravitational anomaly we couldn't see but whose influence was undeniable. The answer, as we now understand it, is both simpler and far more magnificent than a single monstrous object. The Great Attractor is likely a primary node in the cosmic web. To understand what that means, you have to picture the universe on its grandest scale. It's not an even scattering of galaxies in a void. Instead, it's a colossal sponge-like structure. There are vast, empty regions called voids, and connecting them are immense filaments of dark matter and galaxies, stretching for hundreds of millions of light-years. The Great Attractor is a dense intersection within this web, a point where multiple of these massive filaments converge. Think of it not as a single destination, but as a sprawling cosmic metropolis at the junction of several intergalactic highways. It's not one object, but a vast concentration of mass, including thousands of galaxies, all bound together by gravity. This entire region is known as the Laniakea Supercluster, and the Great Attractor is its gravitational heart. But the galaxies we see are just the luminous tip of the iceberg. The true gravitational heavyweight here is dark matter. This mysterious, invisible substance forms the underlying scaffolding of the cosmic web. The filaments are made primarily of dark matter, and the galaxies are just the bright specks of normal matter that have settled into its deepest gravitational wells. So, the pull we feel is not just from the galaxies we can detect, but from an unimaginably vast halo of dark matter that has been accumulating at this crossroads for billions of years. Imagine it as a cosmic basin, where matter has been flowing and gathering since the early universe. This process built the Norma cluster, a rich cluster of galaxies that sits at the Great Attractor's core, but even that is just a fraction of the total mass. Peering into this region is a monumental challenge. The zone of avoidance, the plane of our Milky Way, acts like a thick curtain, blocking visible light. But astronomers are clever, using X-ray telescopes to spot the hot gas between galaxies and radio telescopes to map hydrogen. We are slowly, painstakingly, creating a map of this hidden territory, revealing what's been concealed for eons. The existence of the Great Attractor fundamentally changes our perspective. It forces us to rethink our place in the universe. Our galaxy is not an island but a traveler on a cosmic river, moving at over 2 million kilometers per hour. We are part of a vast, interconnected web, a dynamic and evolving structure shaped by forces we're just starting to comprehend. It's a signpost, not just for our destination, but for the fundamental battle playing out across the cosmos. The tug-of-war between gravity, which builds these incredible structures, and dark energy, which seeks to tear the universe apart. Its story is a perfect example of the scientific process, turning a simple observation, the peculiar motion of galaxies, into a profound mystery that challenges our imagination and pushes the boundaries of our technology. And it leaves us with a thrilling, humbling question. If something this massive, this influential, could stay hidden in our own cosmic neighborhood for so long, what other, even grander secrets does the universe still hold?